The universe has a story, a beginning, a middle where we are now living, and perhaps in some distant future, an end. Today, we will tackle three known theories that explains the origin of our universe. Big Bang Theory is the most popular theory of our universe origin. George Lumet proposed this theory in 1927 to explain the recession of the galaxies within the context of Albert Einstein's theory of relativity. The Big Bang Theory believes that around 13.8 billion years ago, everything in the entire universe was condensed in an infinitesimally small singularity, a point of infinite denseness and heat. In a span of seconds, the universe explosively expands and stretches from a smaller than a single atom to bigger than a galaxy, and it kept expanding at a phenomenal rate. Big Bang Theory was supported by observational evidences, which includes number 1, the expansion of the universe. Edwin Hubble's 1929 observation that the galaxies were generally receding from us provided the very first clue that the Big Bang Theory might be right. Number 2, the abundance of the light elements such as hydrogen, helium, and lithium. Number 3, the cosmic microwave background. So this cosmic microwave radiation is the remnant heat left over from the Big Bang. According to Big Bang Theory, the fate of the universe is governed by the density. If the density of the universe is less than the critical density, then the universe will expand forever. Or if the density of the universe is greater than the critical density, then the gravity will eventually win and the universe will collapse back on itself by the so-called Big Crunch.
Personally, the Big Bang Theory is convincing, for it is the most simple explanation of how our universe began, based on the evidences that we have as of now.
British scientists Sir Herman Bondi, Thomas Gould, and Sir Fred Hoyle first proposed the idea of steady-state universe theory in 1948. Unlike the Big Bang, the steady-state theory believes that the universe is always expanding, but maintaining a constant average density, with matter being continuously created to form new stars and galaxies.
This idea is supported by the redshift evidence. The steady-state theory assumes that the star, an object of constant size and weight, is always in the same place in space. Thus, redshift supports the steady-state theory because redshift is the same regardless of the distance to a body. According to this theory, matter is continuously created to form new stars and galaxies at the same rate that older ones fade away due to their expanding distance, accelerating recession. No, the redshift data is in favor of this theory, but the CMBR is not. The steady-state idea lost popularity once the CMBR was found and is no longer seen to be likely. Einstein first proposed this theory in the 1920s in response to the model of the expanding universe. The initial model largely failed due to the second law of thermodynamics: entropy can only increase. However, this model has been expanded on and exists in several more sophisticated forms today. Alexander Friedman was a mathematician who developed this idea in the form of mathematical equations in 1922. It was Richard Tolman who made the whole approach of the oscillating universe for the first time in 1934. For George Gamow, this fact suggests that the expansion of the cosmos will become slower and slower until it reaches a point where it no longer occurs, but rather sinks into another cosmic era. According to the oscillating universe theory, the cosmos goes through cycles of expansion and contraction. Eventually, all the matter in the universe would get hotter and brighter and eventually collapse together in an event termed the Big Crunch. Then a second Big Bang would occur, resulting in a new universe. Many scientists argue that the universe will not expand to the point of singularity through the quantum effects of gravity. Accordingly, these forces will cause the universe to continue expanding. To reinforce this idea, scientists rely on the evidence of cosmic microwave background radiation, or CMBR, which indicates that the universe is most likely to reach a big freeze or heat death. Oscillating universe theory discusses that the universe is expanding and will contract once all the energy after the Big Bang is used up. The collapsing of the universe will then lead to the formation of a new universe. Not really. The main obstacle with the oscillating universe model is the second law of thermodynamics.